My name is Adnan Abdulhussein, and I'm from Bitnami. And we are two members of the core Helm team. And today we're going to re-deliver a talk that we gave at KubeCon, which is delivering Kubernetes apps with Helm. So we're going to go through what Helm is and show you how you can use it and show you how it's useful for you in a team environment.
So when we look at Kubernetes, we think of it and we see it as a workshop. So if you look at this workshop, it contains a bunch of tools, all kinds of tools that'll let you build all kinds of things. Some of those things might be a basic table, some basic furniture, or you can build something magnificent and beautiful and intricate and complex and multi-tier. But how many of us actually build our own furniture? By a show of hands. So there's always one or two, but most of us don't want to build our furniture from scratch. What we'd rather do is go to some place like IKEA, where somebody has already designed some beautiful furniture for us with our living spaces in mind and our own preferences, and all we have to do is go pick it out, and then take it home and assemble it. So there's this concept here of build versus assemble. And what we found was that we'd rather do the assembling and not so much of the building ourselves most of the time. And the thing that we needed to do that was a way or a tool to help us manage a group of Kubernetes resources as one unit. So we built this thing called Helm. So let's go back to that IKEA metaphor for just a second. Say you walk into this wonderland that is IKEA, and you're shopping around for things that you need, and sometimes for things that you don't actually need but really, really want. And what you walk out with are these packages of pre-built furniture. And that gets you that much closer to having the magical living room of your dreams. In a similar vein, Helm gives you these pre-configured, pre-built applications or application components that you can then use to install into your Kubernetes cluster. And that is actually really powerful, because if you want WordPress running on Kubernetes, you don't have to build that yourself. If you're trying to run MySQL in Kubernetes, you don't have to start from the ground floor. And you definitely don't have to figure out how to run Jenkins in Kubernetes from scratch. Somebody's already done that for you. They've built a package, they're willing to share it, and they've even baked in their own knowledge of Kubernetes and Kubernetes best practices into it. And that gives us all time for two things. More time to become production ready with less effort, and more time to go to all those hipster coffee shops all around San Francisco that we know and love. So packages in our world are called charts. Charts are a way to define an application. So a single chart has three components. The first is it has metadata. This metadata might be something like who authored the chart, what version is the chart at, maybe a description, where your images live that you're referencing in your chart, things of that nature. And it also has, and the biggest piece, are Kubernetes resource definitions. So the bulk of the chart is actually the Kubernetes piece. And these resource definitions can be templated or not templated. And the last piece is the documentation. So this is instructions for how to use the chart, and what the chart actually is, and what it does, and where it came from. And these charts live in something called chart repositories. And Adnan, so graciously, will explain all of this more in detail later. So if you want to use Helm, you can grab it from the GitHub release page or from Homebrew. And the first command that you run to get started with Helm is helm init. And helm init does two things. First, it installs, first it configures your local environment to work with Helm itself. And then it also installs this thing called Tiller into your running Kubernetes cluster. So Tiller is a humble pod that lives his life in Kubernetes itself. And every time you install a chart into your cluster, it creates this thing called a release. And a release is basically the installation of the chart and some metadata. So it contains all of the resources that actually got created in Kubernetes and references to those when you install your chart. So when you install your chart into Kubernetes, you get a release, and that's a big piece of it. So let's see Helm init in action. Oops, I did this wrong. Yeah, okay. Oh, there we go. Can everyone see this okay? Okay, so what happened here is we ran the Helm init command, and it configured our local environment, and it said it installed Tiller. But let's actually go view what Tiller looks like. So if you grab all your pods in the kube system namespace, you'll see the Tiller pod. And the Tiller references, every time you create a release, it'll create a config map, which stores all the information around your release, and it'll reference the release in the kube system namespace. All right. I think we're okay with that. And then the next thing you'll want to do is actually install a chart into your cluster. So let's see what that looks like. Okay, so say you have an application, say you want to install WordPress into your Kubernetes cluster. So you'll go in and you'll search for WordPress. And here we see that we have one result. It was a WordPress chart in the stable repository. Charts are always namespaced by the repository they're in. And if you want to see other charts in that same repository, you can use the search command to do that as well. So we'll use the install command to actually install the stable WordPress chart. And here it did a few things. So let's go and figure out what it did. So the first thing it did was it fetched the WordPress chart from the repository, and then I created a release with a randomly generated release name. So you'll see here that we got Wobbling Mule. And it'll give you some metadata and all of the resources that were created as a result of the installation of the chart. And this is what gets stored in your release. And at the very bottom, you'll see that there are notes. This is like a nice, helpful message that your chart author has left for you. So these are like instructions on what to do next. So here we see that if we grab the service IP that was generated, and we can go visit the WordPress site. We'll do that. And then we'll go to the actual IP address. And we'll see that WordPress is up and running. And we can log in with the default credentials that were stated in the notes, which was the username's user and the password's Bitnami. And that's really it. So you can also use the list command to list out all of your releases. You can use the get command to grab a release's details. So if you want to see what manifests actually got generated, if you templated your chart, then you can do that. And you can also run the Helm status command to see the status of your release. So that's where are all of your resources, and are they running or not? Are they okay? So you can see that using the status command. All right, so say you have a chart, right? And your WordPress site is running fine. You can post things. It's all good. This is what happened at KubeCon. So we see that we have some data here. And if we go back, we'll notice that the WordPress is running on version 4.5.3 and that an update is available. So what do you do from here? If there is an upgrade, or if there's an update available, you want to upgrade your application, and you can do that very simply using the Helm upgrade command. So here we'll run Helm upgrade with the release name Crazy Joey. You should always use the randomly generated release names because they're fine. We passed in the chart that we wanted to upgrade to. And let's see what actually happened to our actual pods, our resources. So here we're recreating the WordPress container. And let's just watch that. Oh, and it's running. And now it's going to be ready, maybe. I don't know. It's pre-recorded, so I'm hoping.
You never know.
And if we refresh the page, we'll see that we have WordPress 4.6.1, which is the one that we wanted, and we still have all of our data. So it's really simple to do application upgrades in Kubernetes for your components using Helm. And I might have X'd out of the presentation too. Okay. All right, so we installed charts, we upgraded a release. That's my reaction every time an upgrade works. And you can use the delete command to delete all of the resources that were associated to your release using the Helm delete command.
Cool. So we've seen how you can actually go and install your first chart, and also how you can go and manage an application running in your cluster with Helm. But you might be wondering, how do you actually go and create your own, or package your own application as a chart? Well, Helm makes this really easy with the create command. You can simply run helm create my app, and you'll get a directory structure that looks like this. So this is what an unpackaged chart looks like. And we'll go through and navigate this directory structure in more detail. So the first place you want to look is in the templates directory. If you're already... Hey. So how does it connect? So it actually uses the same, it uses the kube config, so the same way that kubectl connects to your cluster. So in the templates directory, if you're already deploying applications to Kubernetes, and I'm assuming most of you here are, you already have written some deployment files or service files that you can essentially just put into this directory, and you'll have a working Helm chart. But on top of this, Helm gives you some extra features that make your application releases that much more powerful. So the first is that Tiller will run through each of the files in the templates directory through the Go template rendering engine. So this allows you to do really awesome stuff like this. So in this example, I've got a deployment, and you can see that I'm interpolating some values. And these values are defined in my values.yaml file, which really is, you should look at as the API for your chart. It's where you want to expose any configuration that you want to expose to users. So in this example, I've got a value for the port that my service runs on, and I'm interpolating it here in my deployment file. But I can also interpolate that same value in my service file. So if I wanted to change that, I only need to change it in a single place. And going back to the idea that it's the API for users of your chart, this is how a user at install time would override a configuration that's in your values. So here you can use as shown, you can use the set flag in the install command to override a value. Or for more complex configurations, you may want to provide your own values.yaml file to override multiple properties. The second way Helm makes your deployments more powerful is using hooks. I'm glad someone laughed. So hooks are, so Helm essentially lets you hook into the deployment lifecycle of your application. And you can do this by specifying any Kubernetes resource as a hook. And the way you do this is by adding this annotation. And you can have a post pre-install hook for installing, upgrading, rolling back, and deleting resources. And these are normal Kubernetes resources. So you could decide that you want a config map or a secret to be installed before any other release is installed. But if the type of resource you choose is a job, then Helm will be a bit more clever. It'll actually block and wait until the job is completed before continuing with that deployment. And furthermore, if the job fails for any reason, then the Helm will mark the release as failed. So this is really useful if you want to do something like a migration needs to run before you upgrade your application. And in this case, I'm sleeping for 10 seconds. So after all my resources are installed, it's going to just sleep for 10 seconds, and then Helm will return back to me and tell me that my release is fine. Now, as you're building out your chart, you may find that you need to bring in some dependencies. If I'm building a WordPress chart, I need to depend on a database. And I know a MariaDB chart exists, and I don't need to create my own. So Helm gives me a way of bringing in dependencies, and this happens in the charts directory. I can essentially vendor in any chart, and Helm will make sure that it installs it at the same time as the outer chart is deployed. Now, if you find yourself copying in a dependency in multiple charts, then you may want to make use of the requirements.yaml file, which allows you to lay out what dependencies you have and then simply run a command to automate the fetching and pulling of those dependent charts. When you come to document your chart, as Michelle said, part of the chart is documentation. And there are two ways to do this. There's a README file, which generally, if your chart is in a Git repository, will be the first place that someone will look at your chart. So this is where you want to describe what the chart is, maybe list out any prerequisites. For example, it requires Kubernetes greater than 1.4, or you need PVC dynamic provisioning, or things like that. You can also list out the configuration options in more detail and talk about the defaults, and also maybe point out some of the life cycle, like installing the chart, upgrading, and rolling back. Then there's the notes.txt file, and Michelle touched on this in the WordPress demo. You can use this file to list out any post-installation steps for the chart. And because it's in the templates directory, you can use the templating to print out working commands. Like in the WordPress example, we were able to print out a working command that knew the release name to get the actual name of the service and get the IP address that way. Finally, there's a chart metadata piece, which, again, Michelle touched on. And it contains the description of the chart, some keywords to power Helm search, the maintainers of the chart, and the sources for the Docker images. But it also contains a semantic version for your chart. And this doesn't necessarily have to be the same version for the thing that you're packaging. You could choose to have a different version so that if something in your chart changed that was a breaking change, you could use the semantic versioning standards to communicate that change to your users. So in this case, I would bump a major version. Now, once you've built your chart, you're probably going to want to package it up and share it with people. The way you do this is by building a chart repository. And a chart repository is essentially just a basic HTTP server that serves the tarballs for your charts and an index of what's in that chart repository. And the Helm tools will give you all the commands you need to generate these. And because it's just a basic HTTP server, I could host this on an S3 bucket or Google Cloud Storage bucket. So when a user wants to come and use a chart from your repository, they can simply add that external repository, similar to Git remotes, and install a chart from that repository. Additionally to hosting your own repository, there's a group of folks from the Helm community that are building out an official place for discovering charts. And this currently is composed of two repositories. There's the incubator repository, which is a place for developing and sharing ideas for charts, and also trying out new Kubernetes alpha features. So actually, right now, there's a lot of pet set, or now stateful set examples in there. Then there's the stable repository, which really is just a place for curated and ready-to-run applications. And it consists of things like databases, applications, and more integrated setups for your cluster, like Jenkins or Prometheus. Actually, I think this is a bit out of date. We have a few more charts in the stable repository now. And if you're looking at this and thinking there's a couple of things that you can contribute to this, well, that's great, because it's an open repository, it's public on GitHub, and we're really looking for really great quality chart contributions. So yeah, I'll be really happy if I see some new PRs after this talk. So whilst maintaining this repository, a couple of us are thinking about the best practices for charts and Kubernetes resources themselves. And I wanted to kind of touch on some of the ones that we've seen so far. The first one is kind of quite simple. Your chart should work out of the box. If I'm installing WordPress, I should have everything I need to have a working WordPress at the end of that. I shouldn't have to set up a database beforehand or do anything like that. The chart should come with everything it needs. But you also want to split out dependencies, right? In the WordPress case, I don't want to, in the same chart, deploy my database as well as the application server. I want to split that out because that database can be used and reused, don't repeat yourself, in other charts. And that's one way that Helm can help you reduce or reuse things. The other way is to use the Go template engine, so to reduce duplication in the templates themselves. So if you find yourself copying around labels between manifests, you can actually extract that into a partial and then just include that partial in each of those manifests. So if you want to update a label or add a label, you can just do that in one place. You also want to make sure that your chart is reproducible. Once I package it up and share it, I should be able to give it to Michelle, and it should just work the same way it did on my cluster. And there's generally two ways that you can ensure this, right? You can make sure that your templates are as declarative as possible, and you should also be making sure that you're referencing immutable image tags or content charts, so that the image that you're pulling is the same one that the chart was intended to be deployed with. Finally, the chart should also you should also expose the right API to your users through the values.yaml file. So any application configuration, secrets, Kubernetes constructs like persistence and resource requests and limits should all be easily configurable through the values.yaml file. And if someone just wants to do the simple Helm install WordPress case, they should also get a sane and secure default out of the box there as well. So I want to step back a little bit and talk about some of the design principles that we chose with Helm, and also explain why we think that's helpful for teams. So the first way is that we wanted to make it really easy to get started with existing charts. And this is why we have the stable and incubator repositories. Kubernetes is a new thing. A lot of people are trying it out. And the fact that you can use Helm and not necessarily know too much about Kubernetes and go and install WordPress is really cool. And then you can go back and see, oh, it's using this deployment, it's using this service, and you can actually learn about Kubernetes constructs this way. But when you actually want to go and build your own chart and package your own application for Kubernetes, that should be easy too. And Helm gives you all the tools that you need to go and do this. And when you go and share that, you can also easily stand up a repository and start sharing that with people. Or if you want to contribute a chart back upstream to stable, that's really easy. Just create a pull request. We don't think that your application release stops after a Helm install, after that initial installation. There's always a need for managing that application lifecycle over time. And Helm gives you the tools you need to do that as well. So that's the reason we added upgrade and rollback and all these other tools. You can also see the history of your release and hook into the lifecycle using hooks. Whenever there's a new cool thing out there, like Kubernetes or a new ecosystem, you always have to rethink about the way you do things and how you release applications. We didn't want we didn't want that to happen with Helm. So we took from existing paradigms like package managers and command line tools that people are already comfortable with, and decided to make Helm borrow ideas from that so that you can easily fit it into your existing CI/CD pipelines and shell scripts. Finally, the cluster is the source of truth for what's running in it. And so if I go and deploy something on Friday at like 5 p.m. because, what could possibly go wrong, and I decided to take off, and an hour later, of course, something goes wrong. Michelle, who's poor soul is around, and she has to figure out what happened and go into the cluster. She's able to do this, right? She can just download the release, fetch the release, and figure out that, Adnan changed this value, and this caused this inconsistent state, roll back, fix the deployment, and roll out the new deployment. And that should be really easy to do. And Kubernetes does a good job of managing the state of your resources in your cluster. So Helm just piggybacks off of this and manages your releases and queries the Kubernetes API to get that state. So it's not tied to any individual developer. So those are 5 reasons that we think that Helm really fits into the workflow of teams.
So today marks a really special day. not that one. Today marks a really special day because we actually just released a Helm 2.0.0, so version 2 of Helm. In the first version, you could really just install and delete applications, and now you can do much more. And we're really, excuse me, we're really excited about that, and we just want to take this opportunity to thank the community members. We take every opportunity really to thank the community members. There are over 65 individual contributors to Helm. I think 68 now is the exact number. It's only a year old. There's lots of activity in the Slack channel, so if you're interested, we'd love to have you. If you have questions, please join. Everybody's in there chatting away every day at all hours, so feel free to do that. Our public developer meetings are also open every Thursday, 9:30 a.m. Pacific, and that's just a place for us to do stand-ups if you're contributing to Helm and ask questions and then do demos of cool things that you want to show off. And then we also have a parent SIG. So a SIG is a special interest group. The SIG-Apps is our special interest groups for applications is our parent, and we have weekly updates there, and that's on Monday at 9 a.m. Pacific every week. So I hope you'll join us, and thank you so much for listening.